Hello everyone. We're going to take a look at a third theorem to show that a quadrilateral is a parallelogram. So this is another tool where we can start off with a quadrilateral, and if we know some characteristics of that quadrilateral, we can determine whether or not it is a parallelogram. In this case, our given information is we have one pair of opposite sides that are parallel and they are congruent. So in my specific quadrilateral I have, the one pair of opposite sides I'm going to look at is BC and AD. So that pair of sides, they are parallel to each other and they are also congruent. So that's what we're starting with. And again, I want to show that this is a parallelogram. So in order to do that, we need to use the definition. The definition says that the opposite sides are parallel. We already know that one pair of sides is parallel. I just need to get that the other side is parallel, and then we can use the definition. So for our proof, as usual, let's start with our given information. So here we are given that we have this one pair of sides, of opposite sides, that they're parallel and they are congruent to each other. Okay. The next step, which is something that we've seen a couple times now, but we're going to draw in a diagonal. What this does is it splits the quadrilateral up into two triangles. I can prove that these two triangles are congruent to each other, and then I can use some corresponding parts to get the other information I need. So, draw in diagonal, and we did BD. Okay, so I want to show that these two triangles are congruent. I have one pair of sides that are congruent to each other. Because these lines are parallel, I can look for some angle relationships. Here we have some alternate interior angles. So that's going to be the alternate interior angle theorem. So by the alternate interior angle theorem, we get this pair of congruent angles. So angle ADB is congruent to angle CBD. So now we have a pair of sides, we have an angle, and then we have this shared side in the middle. So we know that BD is congruent to itself, and that's always the reflexive property. And with that, we now have our side, we have an angle in the middle, and then we have another side in both of these triangles. So then we know that the triangles are congruent to each other. So triangle ABD is congruent to triangle CBD, and the theorem we're using is side angle side congruence theorem. Great. So now that I know that these triangles are congruent, I know that their corresponding parts have to match up. So essentially what I'm trying to get to, remember, is that this other pair of sides are parallel. So I want to get the other pair of alternate interior angles within this. So these are the ones we used to get the triangles congruent, but because they are corresponding parts, I know this angle ABD, that has to be congruent to this angle CDB. So then angle ABD is congruent to angle CDB by corresponding parts. And if those angles are congruent, they are a pair of alternate interior angles for AB and CD. So we know that AB is parallel to CD, and that is the converse of the alternate interior angles theorem. Okay, so we already knew to start with that we had one pair of parallel sides. Here we just got to the second pair of sides is also parallel. So then we can finish up. Therefore, quadrilateral ABCD is a parallelogram. And the reason we know that is just the definition. Okay, so another method, another way that we can justify that something is a parallelogram, in this case starting with one pair of sides that is parallel and congruent to each other, then we know that it is a parallelogram.